kind of starting off with your next service, which is your VPC. Now, VPC is one of the very important service that we have in AWS. All right, and this is something that you will be using with all the other services that you have in AWS. Okay, like for example, you want to launch an instance, you will use a VPC for that. You want to launch a database, you will use a VPC for that. So VPC is something that is very commonly used when we talk about your resources in AWS. Almost all the resources, especially which is needed networking, we make use of VPC for that. All right. So again, like I said, this is a very important service, and make sure you try to spend on this as much as possible. Okay. If not, it can be difficult for you to work with AWS itself, because this is one of the very core service that you have. Right. So VPC, it stands for Virtual Private Cloud, and this enables you to launch your resources, all the AWS resources, into a virtual network. All right. So here you will have everything like your subnets, your firewalls, your gateways, your route tables, all those things are available here also. All right. So this enables you to launch your resources. The resources can be your EC2 instances, your database, all those resources into a virtual network. Okay. So this VPC, it's a virtual network that you are going to define. So this virtual network, it closely resembles a traditional network, like how on the on-prem, in your on-premises, whatever the network that you would set up, the hardware related things, your VPC resembles the same thing. Okay, so that you would operate in your own data center with the benefits of using the scalable infrastructure of AWS. So your VPC also provides the same thing for you, but in addition to that, you also get the scalability. So you can scale up the VPC whenever you want. Now, until now, we have been using the default VPC. So to launch our instances, so until now, I know we were launching our instances, right? To launch these instances, we have been using a VPC. Okay, so this is your default VPC. So whenever we sign up to the AWS, AWS will create one default VPC for us. Okay, and that default VPC is what we have been using until now to launch our resources. So whatever the resources that you're going to create, it could be your database or your instances in this case, right? It has been running in our default VPC only. All right. However, at an organization level, you may not use the default VPC simply because your default VPC is not customizable. Okay, you cannot customize it the way you want it. That is where we can make use of your custom VPC. So you'll be creating additional VPCs based on the requirement that you have, and then you will be kind of deploying your applications on this custom VPC. So here, if you see, when I'm launching an instance, by default, this will select one network for us, which is your VPC. Okay, so by default, so this VPC, if you go to the VPC service, you should be able to see. So this is the VPC service we have. That's the VPC dashboard. And here, if you see this VPCs, by default, you will see one. Okay, so if you go to this your VPCs, you should be able to see one VPC, and this is your default VPC. All right. So here, if you scroll here, if you see at the bottom, default VPC. So this is the default VPC, and this is something created by AWS. Are you able to hear the background noise? Dog barking.
Yeah, yeah.
Is it too much disturbing?
No,
Oh,
Okay. So this is what we have been using until now. All right. So to launch our resources and all, this is what we have been using. But again, like I said, at an organization level, you won't be using this. You will always create your own custom VPCs. Now, why do we need a custom VPC? There could be many reasons. One, let's say this IP address range that you see, you want to have your own custom IP address. Now, this is something provided by AWS. Okay. Now you want to have your own custom IP address. You want to have your own firewalls. You want to have your own subnets. So basically, you want more control. You want to customize it the way you want it. Now that's where we can make use of your VPC for that. Okay, so until now we have been working with this, but once you start working at an organization level, once you start working on AWS platform, you will always create your own custom VPCs, and then you will start launching your instances, your resources in that custom VPC. Okay, so the whole point of creating a custom VPC is you can easily customize that network configuration. So that's the whole point. You can customize it the way you want it. The IP addresses that you want, the subnets that you want, everything can be customized the way you want it. For example, you can create a public facing subnet for your web servers that has access to the internet and place a backend system such as the databases or the application servers in a private facing subnet with no internet access. So you get to decide that. So let's say, for example, you want to deploy your web application that should have internet access. You can put that in a public subnet. Likewise, let's say you have a database and this database should not have internet access. You can put that in a private subnet. So you get to decide all those things. Now, in addition to that, you can also leverage multiple layers of security, including security groups and NACLs to Amazon EC2 instances in each subnet. So we already know about your security groups. We will be talking more on that. In addition to that, we have one more firewall, which is your NACL. It stands for Network Access Control List. We will be talking more on that later on. But we can use these two things to control the firewall. So like have additional layer of security. Any questions?
No,
Okay.
sir.
So this is how your architecture looks like when we talk about your VPC. All right. So you will have the AWS account. Okay. So here, this is my AWS account. And within the AWS account, you will have one VPC. In this case, by default, you will have one VPC. So here, this is the VPC. Okay. So in my case, here, this is the VPC that we have. Now inside that VPC, we have something known as your subnets. So here, for example, if you see default subnet 1 and then default subnet 2. So here, if you look at the VPC, okay, and it won't show here, but if I go to this resource map, here you can see this is my subnet. So for this VPC, we have 6 subnets. So 1, 2, 3, 4, 5, 6. Now subnets, these are nothing but your availability zones. So US East 1A, US East 1B, US East 1C. So within my North Virginia US East 1, I have 6 availability zones. And for each availability zone, we have one subnet. Okay, so you have the subnets. And within these subnets, we launch our instances. So for example, here, so here if you can see, the VPC, we select the VPC and then we select our subnet. So by default, it is set to no preference. No preference means you're telling AWS, you select one randomly. So out of these VPCs, you select one and launch my instance. However, if you want to choose it, here you get to choose that availability zones, which is nothing but your subnet. So based on the subnet that you select, accordingly, the IP address will be allocated to your instances. Right? And then you have your route tables. So here, for example, if you see, we have the route tables, which takes care of your routings and all. And then you have your internet gateway. So here, that's my internet gateway. And then this is the entries in your route tables. But generally, this is what your VPC is made up of, the default VPC at least. Okay, so you have the VPC. Within the VPC, we have the subnets. And inside these subnets is where we launch our instances, right? Other than the subnets, we have the route tables, which takes care of the routing. We have the internet gateway, which is for the internet access. And then, yes, we have the firewalls, security groups, and all those things. We will be talking more on this, but this is generally what your VPC is made up of. These are the different components that we have for your VPCs. Questions with this?
So actually one question. So what is the difference between subnet and placement group? So we discussed in previous EC2 section. So in placement group, we had some cluster partition. So how it is different from subnet?
Okay. So your placement groups comes inside a subnet.
Okay.
All right. So your subnet is nothing but your availability zones. All right. So your placements is kind of controlling. So by default, what happens is, now let's say I will select let's say I will select US East to one subnet, which is this one. Okay. So what will happen is my AWS will decide. So under this, again, I will have different hardwares, the physical hardwares. AWS will decide on which hardware my server will be launched. Now, let's say within this subnet, I want to control on which hardware I want to launch my instance. Now, that's where I
Mhm.
can make use of your placement groups. So your
Okay.
placement comes inside your subnets or your availability zones.
Okay, got it.
Any other questions?
No, sir.
Okay. All right. So VPCs, it lets you provision a logically isolated section in the cloud where you can launch AWS resources into a virtual network that you define. So the advantage, the main advantage of a VPC is you can isolate your resources. Now, what do I mean by that is uh, let's say for example you have three applications. Okay, so let's say application 1, application 2, and application 3. All right, now you want application 1 to be in its own network, application 2 in its own network, application 3 in its own network. Okay, so you can isolate these resources by making use of your VPC. So I can have three VPCs here. So let's say VPC 1 for application 1, VPC 2 for application 2, and then VPC 3 for application 3. And then I can start deploying my applications within these VPCs. Now, by default, what happens is whatever the resources that I launch in these VPCs, they are isolated. Think of these as three different folders, right? So whatever the data we have in folder 1, I cannot access it from folder 2, vice versa, right? So the same we can apply to a folder 3 as well. So whatever the data we have in folder 3, I cannot access it from the other folders. The same way we are creating a logical partitioning for your resources. Okay, so you will have the complete control over your virtual networking environment, including selection of your IP address range, creation of subnets, configuration of route tables, and network gateways. So with your custom VPCs, you will have the full control of that networking. All right. So you can choose what IP address range you want. You can choose how many subnets you want. You can configure the route tables, how your routings should happen. You can set up your gateways. All of those things will be done by you. Now, the advantage of your default VPC is you don't have to do any of these things. AWS has already done that for you, and the VPC is ready to use. We can straight away start using it. But with your custom VPCs, you have to make sure that the setup is done. Only then you will be able to work with your custom VPCs. Now, whenever we talk about your networks, we have two types of IP addresses. We have the IPv4 and IPv6. So you can use both IPv4 and IPv6 in your VPC for secure and easy access to resources and applications. So generally, when we talk about your IP addresses, they can be divided into two types. We have the IPv4 and then we have the IPv6. We'll talk more on that in some time. So your VPC, it's nothing but a miniature data center in your organization. So it's a mini data center that you're creating. Likewise, you can have multiple mini data centers which are isolated from each other by default. Okay, so your VPC is a sub cloud inside the AWS public cloud. Sub cloud means it is inside and isolated logical network. Any questions?
Hello.
No, sir.
So, all right. So, whenever you launch your resources inside a VPC, other servers which are outside the VPC cannot see the instances that are inside the VPC. Okay. So, let's say I create one custom VPC and I launch my instance inside that custom VPC. Now, any instances that are not part of that VPC will not be able to see the instances or access the instances that are inside the VPC. Okay, so you can launch your AWS resources such as EC2 instances in your VPC. You can configure your VPC, you can select the IP address range, you can create subnets, configure the route tables, network gateways, security settings, and many more things. So basically, you will have the complete control. You can customize it the way you want it. So within the VPC, we have your subnet. Now, what is your subnet? Subnet is nothing but it's a range of IP addresses. So how many IP addresses that you want, that can be defined by making use of your subnet. So maybe you want 8 IP addresses or 10 IP addresses or 20 or 100 or 200. That we define by making use of a subnet. So you can launch AWS resources into a subnet that you select. Use a public subnet for resources that must be connected to the internet. So, whenever we talk about the subnets, generally we have the public subnet and we have the private subnet. You can call it whatever you want, but in general, we have the public subnet. Now, public subnet is the subnet that has access to the internet, and private subnet is a subnet that does not have access to the internet. So your subnet is a sub network inside VPC, and then you have your security groups which are stateful and NACLs which are stateless filtering. So we'll be talking about your differences between your security groups and NACLs um, uh, in some time. All right, but that's what it is. So now, whenever we talk about your networks, all right, we have, I think, we have four types of networks, four or five types of network. I think five. Okay, so we have different classes generally when we talk about your IP addresses. Okay, so we have class A, we have class B, we have class C, we have class D, and then we have your class E. Okay, so we have class A, we have class B, we have class C, uh, class D, and we also have your class E. Now, whenever you're setting up your VPC or any network, you need to first decide which class you want to use. Now, class A will generally have this one, 10, starting with 10. So 10.0.0.0. If you see this, that's a class A network. Class B will be this one, 172.16.0.0. So anything that starts with 172.16, it's your class B network. And then you have your class C, which is 192 192.168.0.0. Likewise, we have, let's see, I'm sorry. So network, so here, so class A, class B, class C, class D, and then your class E. Okay, so these are the five classes that generally we have whenever we talk about a network, right? Let's see. Hmm. So something here, if you see, so this is 224 to 239, and then 240 to 254. Okay, so used for large number of hosts. So class A is what you will very commonly used. Then medium sized networks, class B, used for local area networks, class C. So if you look at your ISP provider, internet service provider, mostly they will be using this class C. And then class D reserved for multitasking. Class E is again reserved for research and development purpose. Okay, so that's what generally we have when we talk about your VPCs. Now, AWS, it supports class A, class B, and class C. So we can use these three to set up our VPC. Okay, so here if you look at the default VPC that gets created for us, it uses this 172 range, which is nothing but your class B. Okay, any questions with this?
No, no.
No.
No, sir.
Okay, so when we talk about your so I told you that you have your two types of IP addresses, right? So you have the IPv4 and you also have your IPv6. Okay, so if you see something like 10.0.0.0, that's your IPv4. So IPv4 is your 32-bit address and IPv6 is your 128-bit address. So IPv6 will be a combination of numbers and characters. So here, this is your IPv6 address. Okay, so here you can see you have numbers as well as characters. So this will be your IPv6 address. Now, in our case, most of the time we are used to the 32-bit address. This is what you will see. A 32-bit, this is nothing but, so this is 8 plus 8 plus 8 plus 8. So 8 fours are 32-bit. So this one will be 8-bit, this one will be 8-bit, 8-bit, and then 8-bit, which makes up for your 32-bit. Likewise, this is your 128-bit. Now, whenever we define our network, whenever we are creating our network, we always give a range. So this last number that you see, /8/12/16, we call that as your CIDR block, CIDR, which stands for classless inter-domain routing. This basically tells you what is the number of IP addresses that you get. So we'll talk more on that later on. And you also have this web app called CIDR.xyz. We can use this also to understand what is the number of IP addresses that you will get. So we'll talk more on this. I'll show you how you can get all those things. But in our case, we are going to use your class A to create the VPC. So this is what we are going to create. So we will be creating one VPC, and this is the range. So 10.0.0.0.0/16. So here if you see 10.0.0.0, that is your class A. All right. And then here I'm giving a number /16. Now that number /16, we call that as your CIDR block or CIDR block. Okay, so it's your classless interdomain routing. It stands for classless interdomain routing. Now this number, it can be anywhere between 0 to 31. So if you see there's a -1, which is nothing but 32. So 0, which is again less than 1. So starting from 0 to 31, which makes up for your 32 bits. Right? So this number over here, the slash number, it can be anywhere between 0 to 31. Okay. Now the lower the number, the highest the number of IP addresses you will get, and the higher the number, the lowest number of IP addresses that you will get. There is a formula for this, how you can calculate this. Okay. So let's say, for example, if I give /16, okay, so that means it will be 32 minus 16, which is equal to 16, and then we do a 2 power 16. So this will give me 65,536. Okay, so 2 power 16, the value is 65,536. That means with this range, I will get 65,536 IP addresses. Okay, so it's a formula. Like I said, this is the formula that gets applied for this, and that's how the number of IP addresses gets calculated. And if you're not sure, like I said, you can use this app CIDR.xyz. That also will tell you the right number. So here, if I go to this CIDR.xyz, here, so 10.0.0.0/16, so gives me 65,536 IP addresses. Make sense?
Yeah.
Yes.
Okay. So first we are going to create a VPC. All right. So we'll go to our VPC, and we'll go to your VPCs, and we'll start creating a VPC. Now, what do you want to do? You want to create only a VPC, or you want to create everything? So when I say everything, you want to create VPC, subnets, routables, network gateways. So all of this can be done in one single shot. Okay. Or we can create them one by one. So first VPC, then subnets, then routable. So we can do it individually. So in our case, we'll go with individually. So let's call this as custom VPC. and you want to go with manual input or IPAM allocated. So IPAM is a different way to allocate the IP address range. In our case, we are going to enter it. So we'll give 10.0.0.0/60. Now, do you want to use IPv6 address? No, because you're using IPv4. If you want to use IPv6, you can provide that also. But in our case, we're not going to use it. Then comes your tenancy. Now, tenancy is nothing but your hardware. This network. So this is nothing but your physical network, right? So there's a physical network that is associated with this. Now, by default, what happens is this hardware will be shared by multiple people. Like let's say if you create a VPC, like let's say Prokshit creates one, Bharat creates one, and then Sedu creates one, and I also create one. By default, what happens is we will be utilizing the same hardware in the Amazon's data center. Let's say you don't want to do that. You want to have your own dedicated hardware. Like let's say if I am creating a VPC, I want to have my own dedicated hardware. Only I should be able to use it. Then I can go with dedicated, where AWS will create a dedicated hardware for it. However, you will have to pay extra money for that. Okay, so that's your tenancy. So we'll go with default and then click on create VPC, and this will create the first component, which is my custom VPC. So you can see here the IP address. This is customizable. Now I have given the IP address range that I want, right? So any questions? This is how you can create a VPC. So we have created only one component. We'll be looking at the other components, but that's how you can create a VPC. Any questions?
No.
No, sir.
Okay. Now, under this VPC, we are going to create our subnet. So for the sake of example, we are going to create two subnets. We will call it as public subnet and we'll call it as a private subnet. Okay, so I'll go to subnet. So this is where you can see all the subnets. Now, all these subnets that you see, these are pointing to one single VPC, which is my default VPC. Okay, so in our case, we'll create a new VPC, and any resources that you create, it will be mapped to a VPC. Okay, so here we'll be selecting the VPC. So in my case, a custom VPC, and then you can give it a name. So let's call this as public subnet, and you can choose the availability zone. So this subnet to which availability zone it belongs. So let's say US 61A, and then again your CIDR block. Now, in this case, I'm giving 10.0.1.0/24. So this 10.0.1.0, I'm basically taking one IP from here. All right. So here, let me show this. So yeah, you can see here, this is the first IP address 10.0.0.1. Likewise, you'll have 2, 3, 4, 5, 6, so on. It goes until 255. And then it will come to 10.0.1.0, 2.0, 3.0, 4.0, and then so on. So out of that range, I'm using one IP address for one of my subnet. Okay. Now in this case, if you see, I'm giving /24. So any idea how many IP addresses that I will get? Again, you can use the formula here. So in our case, this will be 32 minus 24, which is
8. 8.
8.
So we have 8, and then 2 power 8 is
160.
come on. Who's very strong in maths?
Sedu.
Sedu. Sedu, what is 2 power 8? Come on, yeah, it's so hard. So you have 2 to 4, 4 to 8, 8 twos are 16, 16 twos are 32, 32 twos are 64, 64 twos are 128, and 128 twos are 256. So that's what you get. Okay. So if you see here, now I gave 10.0.1.0/24. So if you see this number, the higher the number, the lower number of IP addresses that you will get. Okay, and the lower the number, sorry, the higher the number, the lowest number of IP addresses you will get, and the lower the number, the higher number of IP addresses that you will get. Does this make sense?
Yeah.
Yes, sir.
Okay, so in our case, we are giving 10.0.1.0 slash 24. We'll create one more subnet over here, and this will be my private subnet, and we'll go with this in US East 1B. And for this, we will give 10.0.2.0 slash 24. Now, I cannot use 10.0.1.0 because it is already taken, right? So I have to make sure that my subnets, they have unique range. Likewise, if you want to create multiple subnets, you can create multiple subnets. But for our case, we are creating only two subnets, and this will create our subnet. So I have the public subnet, I have the private subnet, which are running in my custom VPC. Okay. So now we have our VPC, and for this VPC, we have two subnets, the public subnet and the private subnet. Any questions?
No,
No.
sir.
Okay. Next, we will need to create our route tables. Now, what are route tables? Route tables is what controls, once it receives the traffic from the internet, to which subnet it should go. So you can think of it like this, all right? Let's say you have an apartment complex. Okay, so let's say in that apartment complex, you have, let's say, block A, block B, block C, and then block D. Now, let's say you're a new person. So someone from one of that block, they've ordered some groceries. Okay, so let's say I will pick those groceries and I'll go for the delivery. So I'll first reach the main gate. So at the main gate we'll have a security guard. Now that person will ask like, am I authorized? Am I allowed to go or not? All right. So I'm allowed to go. After that, again at each of the respective blocks, again we'll have a security group or people sitting over there, and they will ask, where do you want to go? So I'll say, let's say I want to go to this block A number 102, right? So that person will guide me or tell me that, okay, this is how you have to go. So that routing is what can be done with your route table. So once my traffic comes from the internet, where it should go, should it go to the public subnet or it should go to the private subnet? That routing is taken care by the route table. So for this, again, for each of these subnets, we will be creating individual route table. So one will be my public route table, and again, this will be in my custom VPC. Likewise, we will be creating one more route table, which will be for my private. So this will be my private route table. So public route table will be for the public subnet, and then private route table will be for the private subnet. Now, once you're done creating this, you will need to define the routing. So we have just created it. We have not defined any routing. So if you say this routes, this is where you will be telling how the routing should happen. So I'll come to this in a bit. The next component we have is your internet gateway. Now, what is an internet gateway? Internet gateway can be used if you want to give internet access. Okay, so if you don't have an internet gateway, you won't be able to give, you won't have any internet access. So this is a very important component you have. At any point, if you want internet access, like from the EC2 instance, you want to access the internet, or from the internet, you want to access the EC2 instance, you will need to have an internet gateway. Okay, so now we are going to create one internet gateway for this. So we'll go to internet gateways, and here we'll create a new one. So let's call this as custom VPC IDW, which is nothing but internet gateway, and we'll create this. Now, once you're done creating this, by default, this is detached. So it is not attached to any VPC. So we'll go to actions, and here you can see attach to VPC, and you should be able to select your VPC. Now, one internet gateway can be attached to only one VPC. Okay, I cannot attach one internet gateway to multiple VPCs. Okay, it is one-to-one mapping, one internet gateway for one VPC only. Now, once you're done creating this internet gateway, you can go back to your route table and you start adding the routes. Okay, so I go to my public. For now, we will work with the public route table. Later on, we will come to the private route table. So here I'll go to my routes. I will edit this, and we're going to add a new route telling that any traffic. So 0.0.0.0 slash 0. coming from my internet gateway, which is this one. So this is a rule. Okay, it's a route that we are adding. So what I'm telling here is any traffic that is coming from this internet gateway, okay, send it to my subnet. So edit subnet association, which is my public subnet. So basically what I'm telling here is any traffic coming from the internet gateway, right? You accept that traffic and send it to the public subnet. Do you understand this flow?
Yes, sir.
Okay. So, I mean, this is really important. Okay, understanding this flow. If not, your VPC itself will not work. Now, the last thing we need to set up is our security group, the firewall. So now what will happen is from the internet gateway will get the traffic. It will go to the route table, and route table will tell that, hey, go to this subnet. Now at this subnet level, again, we will have your firewall, right, which will control the access to the EC2 instance. So now we will go and create a security group, create, and let's call this as custom VPC SG, which is your security group. And this belongs to my VPC, which is a custom VPC. And here you add the rules. So whenever we talk about your firewalls, we have the inbound rules and we have the outbound rules. Now, by default, if you're working with your security groups, your outbound rules, all the traffic is allowed. So outbound will be from the server to the internet, and inbound will be from the internet to the server. Okay, so here you start adding the rules. So let's say I want to allow SSH, and we'll allow this from anywhere. So let's say allow SSH from anywhere, and we can add a tag to this and create. And this completes a very basic setup of your VPC. So this is the minimum things you will need to set up your VPC. Anything that is missing in this, your VPC will not work. Okay, so once again, we created your VPC. We created two subnets, the public subnet and the private subnet. We created one internet gateway. We created one route table, and then we have also created your security groups. Any questions until here?
No.
Okay, now that you're done creating your custom VPCs, you can start launching your instances in this custom VPC. Okay, so let me cancel this and we'll again come from here. Let's call this as custom VPC instance. We'll go with this Ubuntu. And then my key pair and all this remains the same. Then when we come to the network settings, again, this will point to your default VPC. To change it, we'll go to edit, and here you should be able to see the VPC. And inside this VPC, we have only two subnets, the public subnet and private subnet. So you can choose in which subnet you want to launch the instances. So we'll talk about the differences, but for now, we'll go with the public subnet. And then auto assign public IP. So by default, so there are a few differences when we talk about your default VPC and your custom VPC. All right. So if you look at your default VPC, here, if you look at the network settings, by default, if you see this auto assign public IP, it is enabled by default. But in your custom VPC, it is disabled by default. So you'll have to enable this. Now, every time you launch the instance, and if you want that instance to have a public IP, you'll have to enable it again and again and again. Now, you can do it in one single shot. So if you go to the subnet that we have created, so if I go to the subnet, under actions, you should be able to see this edit subnet settings. And here you can see this enable auto assign public IPv4 address. And what that will do is every time you select that subnet, it will automatically enable this. You don't have to select it explicitly. And then your firewall. So we have already created a firewall. So here you should be able to see that firewall. Okay. And these are fine. These are some default things. That's fine. But this is how you can select your custom VPC. So that's my custom VPC. I'm running it in the public subnet and I'm selected my custom security group. And now we will go ahead and launch this instance. And this should launch my EC2 instance in a custom VPC. Any questions until here?
No. No, sir.
Okay. Now, if you look at this instance, all right, this will clearly tell you that it is running in your custom VPC. All right. So here you can see the VPC ID. That's my custom VPC, and the subnet ID that's running in my public subnet. Right. Now, one more thing that you can use to validate in which subnet this is running in is you can look at the IP address, the private IP of this instance. Right. So here, if you go and see this one, this is the private IP. So I have 10.0.1.59. If you remember, for the public subnet that we created, we gave 10.0.1.0. So one IP address from this range is now assigned to my instance. Okay. And if you see this number, it says 251. Now, if I refresh this, you see it says 250. That means one IP address has been allocated to an instance, and there are 250 more IP addresses that are available for me to use. So, meaning in this subnet, I can launch 250 additional, another 250 instances. After that, I won't be able to launch. So, think of it like this: you have your theater, right? Your theater has a seating capacity of, let's say, 250 people. Accordingly, you'll have the tickets. As you start giving the tickets to people, you're basically filling the theater, and once the capacity is filled, you won't be able to accommodate any more people. The same way you have your subnets. So this is nothing but your capacity. Okay, how many instances you can launch. I'll talk more on this tomorrow, but pretty much that's what it is. So now my instance is running. This public IP that you see, this is not under your control. This is something assigned by AWS. You can only control the private IP. This IP that you see here, this is what we can control. We don't have the control on the public IP address. Questions?
No, sir.
Now let's try connecting to this server. So again, it's the same. So we use the SSH command to connect to this server. So hold on one minute. SSH -I. And here I will be connected to my instance. Okay, so here you can see 10.0.1.59, which is nothing but my private IP. Now my instance is running in a private custom VPC. Please let me know if there's any questions until now.
No. No, sir.
So your VPC, so Amazon VPC lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So VPC is basically your virtual network that you are creating. Now within that VPC, you have a subnet. So what your subnet? Your subnet is a range of IP addresses in your VPC. So how many IP addresses you want? What is the capacity that you want? We can define that in a subnet. Then you have the internet gateway. So an internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between your VPC and the internet. So this communication between the internet and the VPC can be established by using an internet gateway. an internet gateway. Then you have the route table. So a route table contains a set of rules called routes that are used to determine where network traffic from your subnet or gateway is directed. So this will basically have some rules, and these rules will determine where the traffic from your gateway should go. Should it go to the public subnet or should it go to the private subnet? That information or that rule, we define it in the route table. Okay. Now, whenever we talk about your range, the IP addresses, so here if you see, I told you that we should be having 256 IP addresses, but here it gives me only 251 IP addresses. Now, what's the reason behind that? So, the first four IP addresses and the last IP address in each subnet CIDR block are not available for us to use and cannot be managed or cannot be assigned to an instance. So always you will have -5 IP addresses. So this one also, if you see, ideally I should have 4096, but I will always have -5 IP addresses. So this one is 251. So the first four IP addresses, which is 10.0.0.0, 10.0.0.1, 10.0.0.2, and then 10.0.0.0.3. All these are reserved by AWS. Okay, we won't be able to use them. And then you have 10.0.0.255, which is the last IP address. This is a network broadcast address, and at the moment VPC does not support network broadcast, and this is also reserved by AWS. So you'll always see -5 IP addresses. So the first four IP addresses and the last IP address is reserved. We won't be able to use them. Questions?
No, sir.
So
No.
what you can do with a VPC, you can launch the instance into a subnet of your choosing. So you can now choose in which subnet you want the instances, whether you want it in the public subnet or in the private subnet, whether you want the instances to have the internet access or not. You can decide that. You can assign custom IP address ranges in each subnet. You can configure the route tables. You can create internet gateway. You'll have much better security by using your security groups and NACL. So all of these things can be done by working with your VPC. That's all for today. Tomorrow we will talk about your jump hosts, or we'll talk about your private servers, how you can launch your private instances, and then how you can connect to that private instance. So all those things we will talk tomorrow. All right. I think that's all for today. I'll terminate this and then we'll launch it tomorrow. All right. If there's any questions, let me know. If not, then thank you so much, and I'll see you guys tomorrow.
Thank you. Thank you,
Thanks.
Ravi.
Thanks, guys. Bye bye.